This is Randy Weiss, Small Grain Specialist in the Department of Crop Science at NC State University, and this presentation is 4 keys to high-yielding wheat, and it's based on results that we've found in tests over the last 2 seasons, 2010-11 and 2011-12. The first key that we found is getting right with your soil. And what I particularly mean by that is it's not been unusual, particularly in our coastal plain and tidewater soils in North Carolina, for the wheat to be planted, for it to come up and look pretty good, and then very shortly after emergence, for the wheat to start looking yellow in areas across the field and to appear stunted. And although there are a number of different things that can cause this, the most common cause was having soil pH that was not at the right target. And particularly it was caused in most cases by having a soil pH that was too high, resulting in a manganese deficiency. One of the best ways that you can tell that you're dealing with a manganese deficiency when you're looking at yellow wheat is if you see these greener streaks through the field. Typically these green streaks appear either where you've got tire tracks or anywhere where the soil is a little bit more compacted, and the wheat will show less of a manganese problem and appear to be a bit greener. If you're seeing symptoms that look like manganese deficiencies, it's very important to act quickly to determine if a manganese problem and a soil pH problem is causing this. And the best way to do that is to take diagnostic soil samples both in the bad area and in an area that looks green, and to send those soil samples either to our NCDA soils lab or to a private lab for analysis, and to also take diagnostic plant tissue samples from these 2 areas to send to the Plant Insect and Disease Lab at North Carolina State University. These 2 tests will help you determine if it is a manganese deficiency so that you can correct that, and also take steps for your future crops to make sure that you prevent overliming. It's important to start right when it comes to your soil, and there's no substitute for soil sampling before you plant your wheat. It's important to apply lime, phosphorus, potash, and sulfur as needed based on a soil test, and it's particularly important that you know your target pH that you're liming toward. In North Carolina mineral soils, our target pH is 6.0. In mineral organic soils, it's 5.5. And in organic soils, it's 5. Now, that may seem to be something that all of our growers know and are very familiar with, and yet it's not uncommon that when soils are sampled these days on farm, that those samples are sent to a private lab for analysis, and many private labs are not familiar with the target pHs that we use here in North Carolina to prevent overliming. So if you're using a private lab to set lime levels for your fields, it's very important to make sure that they know that you don't want to lime above a target pH of 6 for a mineral soil. Very important to avoid overliming if you're looking for high wheat yields. Key number 2 to high wheat yields: timely planting. This is a map of North Carolina showing starting planting dates for different regions across the state. We've had tests in recent years in the Lumberton area, shown here by the red star, where the map indicates optimum starting planting dates for wheat between October 25th and October 30th. And we've also had tests in the Salisbury area where optimum starting dates are between the 15th and the 20th of October. At these locations, we've planted during these optimal starting dates, and then we've also followed up with tests where we planted about a month later in mid to late November. Results at both of these locations have been similar, so I'm just going to show you results from last year's tests in Lumberton. This is the results of a seeding rate test, and where we planted the seeding rate test in a timely way back there at the end of October, that's this upper line. The yields at our best yields at our optimum seeding rates were about 120 bushels to the acre. for seeding rates between 1.1 and 1.3 million seeds per acre. Where we planted a month later, around Thanksgiving, that's this lower, darker blue line, our best yields were achieved at somewhat higher seeding rates. That's consistent with needing higher seeding rates when you're planting late. But even at our best seeding rates, between 1.3 and 1.5 million seeds to the acre, we didn't even make 90 bushels to the acre. A difference of 30 bushels to the acre based completely on planting date, and which could not be made up by increasing seeding rates and planting at a higher seeding rate. So planting date was very important. Here are the results of another planting date test. This was a pop-up fertilizer test. We were interested in whether using an in-furrow pop-up fertilizer could help make up for late planting. So the light blue bars, like the ones shown here that I just indicated with the red arrow, are for our timely planted wheat back at the end of October. And this particular bar is the yield for the check treatment that did not get any in-furrow pop-up fertilizer, and that yielded also about 120 bushels to the acre. Looking at in-furrow applications of nitrogen or phosphorus really had a very small effect, maybe about 4 or 5 bushels to the acre increase over the check, also coming in somewhere between 120 and maybe 124 bushels to the acre. So a little increase by using a pop-up fertilizer when planting on time. What about planting that 1 month late? That's indicated here by these dark blue bars. Again, this is the untreated or the check yield coming in at about 85 bushels to the acre, maybe a little bit more. And using a pop-up fertilizer really had no impact whatsoever. Yield still coming in around 85 bushels to the acre. So once again, we're looking at a 30 to 35 bushel difference in yield between planting on time and planting late. And whether we're looking at an increasing seeding rate, as in the previous slide, or using a pop-up fertilizer, as shown here, neither of these two things could make up the loss in yield due to planting late. Now these tests were in Roland. The tests that we had in Salisbury, the differences weren't quite so great. Their planting late resulted in about a 15 bushel yield difference. Lower yields planting around Thanksgiving compared to planting on time, but once again, increasing seeding rates or using a pop-up fertilizer could not make up that difference. So planting in a timely way is very important if you want high yields here in North Carolina. And if you want a copy of this map, the best place to go is online to the Small Grains Production website at www.smallgrains.ncsu.edu. Key number 3, disease control, something that's very important for most of our growers in North Carolina. In the last year, and over actually several of the last years, we've had very warm weather, and that's resulted in a lot of powdery mildew across most of North Carolina. Now, the best defense against getting powdery mildew is choosing resistant varieties, and we'll talk about that in just a minute. Leaf rust was also a serious disease this last year, and also really over the last 2 years. It also likes hot, dry weather, and last spring in 2012 we had epidemic levels of leaf rust in many areas of the state. Once again, the best defense against leaf rust is choosing to grow a resistant variety, and we'll talk a little bit more about that defense in a few minutes. Well, what about fungicides? If we're going to use fungicides to help if we get a powdery mildew or leaf rust problem, when is the best time to apply that fungicide? And lots of growers have asked, should we be applying a fungicide with our top dress fertilizer, or should we be applying that fungicide later? And here's some results from a fungicide test that we had out last year in 2012 in Roland, North Carolina. This bar represents the check or the unsprayed yield. It's coming in at about 105 bushels to the acre. These two bars represent the yield from where either twin line or quilt was applied at top dress time along with nitrogen fertilizer in the spring and early March. And we got a little bit of a yield bump, maybe somewhere between 4 and 8 bushels to the acre. All of the bars on the far left of the graph are cases where either twin line or quilt were applied at somewhere between flag leaf and heading. And clearly that's where we got the best disease control and the highest yields. So from our check with about 104 bushels to the acre to where we applied a fungicide somewhere between flag leaf emergence and heading where we got over 120 bushels to the acre. A tremendous increase through the application of a fungicide, and particularly with a fungicide timed later in the season between flag leaf and heading. So what's the best way to get timing right if you're trying to control powdery mildew and leaf rust? The first question to really ask is, do you as a grower have time to scout your fields in the spring for these diseases? If the answer is yes, then the best thing to do is scout your fields, and if you have powdery mildew covering 5% or more of your upper leaves, or leaf rust covering 1% of the leaves, then it's time to spray a fungicide. If you're a grower who doesn't have time to scout your fields, then the best time to time an application of a fungicide is between when the flag leaf is fully extended and when the heads are just starting to emerge. Somewhere in that interval between flag leaf emergence and before the heads are out is a good time to pull the trigger and get that fungicide out there. Key number 4, variety selection. And I refer to this as the master key because it's probably the most important thing that you as a grower do to assure high wheat yields on your farm. Let's look at some results from variety tests that we've had out, particularly in this last year. This is a variety test we had in Roland, North Carolina in 2012, and notice that our highest yielding variety produced over 120 bushels to the acre, compared to the lowest yielding variety that only came in at about 50 bushels to the acre. This is about a 70 bushel difference just depending on what variety you chose to grow. Now it turns out that this was a high disease location. We had some powdery mildew and we had basically a leaf rust epidemic at this site late in the season. So you may ask, is variety selection important if you were going to apply a fungicide? Wouldn't application of a fungicide wipe out some of these variety differences? Well, let's look at that and see if that's the case. Now let's start by looking at the blue bars in this graph. The blue bars are exactly the same as the graph I just showed you. They're variety yields in our variety test where we did not apply a fungicide. And once again, the highest yielding variety is the blue bar over here on the left, coming in at about 120 bushels to the acre. And the variety over on the right is coming in at about 50 bushels to the acre. That's our lowest yielding variety in the absence of a fungicide. Now the red bars are the additional yield that these varieties produced when they were treated with a fungicide both at top dress and a second fungicide between flag leaf emergence and when the heads came out. So in most cases applying a fungicide had a pretty dramatic improvement in yield. But let's take a minute and look at the varieties that did 115 or more bushels to the acre. These are all the varieties that have red lines or yields in the red above the line that I just drew across the graph. Notice that most of those varieties, most of those have an R just above the bar showing their yields. The R indicates that these varieties have some varietal resistance to leaf rust. So it turns out that in this particular location, the best way to get high yields was, one, to apply a fungicide, and second, to choose varieties that had resistance to leaf rust. That combination of variety selection and fungicide application is what produced the best yields And we'll come back and look at this again in just a minute. What about a location where where disease levels were very low? And that would have been, for example, in our test in Salisbury in 2012. Again, on the left is our highest yielding variety coming in at just under 115 bushels to the acre, and our lowest yielding variety on the far right coming in at 90 bushels to the acre. So in the absence of disease, we have about a 20 bushel difference between the best yielding and the lowest yielding varieties. So variety selection, even in the absence of disease, can really make a tremendous difference. Where can you get information about variety performance and recommendations? The best place is through the 2012 Wheat Variety Performance and Recommendations newsletter that comes out of my office every year in July and is available right now either from your local county extension office or online at www.smallgrains.ncsu.edu. Let's take a closer look at this table and the information. The varieties that are listed in red are ones that over the last 2 years have been above average yielding. The varieties listed in blue are varieties that have tended to yield right about average, and those listed in black at the lower part of the table are varieties that have been yielding below average. The first column after the variety name is test weight information so that you can choose varieties that are not only high yielding but may also be high in test weight. The second column is heading date, and we'll talk about why that's important in just a minute. And all the subsequent columns are resistance to important diseases and insect pests here in North Carolina. Let's look at how you'd use this information to make some variety selections. The first step is to choose at least 3 varieties to grow on your farm. No single variety is always going to be the best yielding across years or even from one field to another. So it's important to choose at least 3 varieties to increase the probability that at least one of those is going to be a good yielding variety on your farm. And certainly the best place to pick those varieties is probably going to be from the list of the above average or average yielding varieties in this list. The second step in choosing good varieties is to think about ways to avoid spring freeze injury. And the best way to do that when you're thinking about variety selection is to limit the number of early heading varieties that you choose to grow on your farm to 1. Early heading varieties are the most likely to suffer from spring freeze. So if you limit yourself to only 1 early heading variety out of the 3 or more that you're going to grow, that will greatly reduce your risk to having spring freeze occur in a way that's a problem at your harvest. Step number 3, get resistance to at least 1 key disease. As I showed you earlier in our yield data from our variety test, in places where powdery mildew or leaf rust can be a problem, our highest yields were achieved when we combined the application of a fungicide with variety resistance. So what we really need to think about is choosing varieties that have resistance to either powdery mildew and or leaf rust when we're making variety selections. Let's look at those in more detail. Here are some of the above average varieties, above average yielding varieties from the newsletter that have resistance to either powdery mildew or leaf rust or both. AGS 2035, Dynagrow 9012, Pioneer 26R10, Southern States 8500, Terrell TV 8848, and USG 3120 all have resistance to leaf rust. Dynagrow Dominion, NC Cape Fear, Southern States 8340, USG 3555 have resistance to mildew. And the last 4, Dynagrow Shirley, Featherstone VA 258, Pioneer 26R20, and USG 3438 have resistance to both diseases. And what about varieties that were rated as average yielding? Those that are resistant to leaf rust are the first 6, AGS 2026, Dynagrow Baldwin, Southern States 5205s and 8404, and USG 3201 and 3592. The next 4 with resistance to powdery mildew, Southern States 520 and 8700, SY 9978 and USG 3209, and the last 4 that are resistant to both, or rather that are resistant to both diseases, are Dynagrow 9171, NC Yatkin, Southern States 8641, and Terrell TV 8525. And finally, the last step in choosing varieties that I think is important is to think about variety resistance to head scab. That's indicated all the way over here on the right side of the newsletter and the table. And it's important if you have varieties that are rated as MS, or moderately susceptible, or S under head scab for susceptible, to monitor the weather while your wheat or those varieties are flowering in the spring. Wheat tends to flower in the period of about 5 to 7 days after heading. And so if you've got varieties that are moderately susceptible or susceptible to head scab, it's important to be monitoring the weather, and if the weather is very warm and moist, to be prepared to spray a special fungicide for head scab. And those fungicides are Carumba, Proline, or Prosaro, or as a last case option, Folicure. Folicure has some activity against head scab, but is not as effective as the other 3 that I just mentioned. You're less likely to have a problem if you've got a variety that is moderately resistant to head scab. But if you look under the column that shows resistance to head scab, one thing that jumps out right away is that our highest yielding varieties and many of our average yielding varieties do not have moderate resistance to head scab. So you're likely to be selecting varieties that are susceptible and are the most likely to need one of these special fungicides at heading if the weather is warm and humid. Remember that if you're growing one of these susceptible varieties to head scab on your farm and the weather is warm and humid, which means you may have a head scab problem develop, it's important not to apply a fungicide that's a strobilurin, because strobilurin fungicides can actually make head scab worse. So, 4 keys to high yielding wheat: getting your soil pH right, timely planting, disease control, and finally, variety selection. If you'd like more information on these keys, go to my website at www.smallgrains.ncsu.edu. There's information there on each of these topics, and the small grain production guide is there as well, which is also available from your local county extension office. And all of the information that I've just shown you from tests across the state in North Carolina were made possible by funding from the North Carolina Small Grain Growers Association. And we thank all of you for your checkoff dollars that made that funding possible. Again, this is Randy Weiss. I'm in the Department of Crop Science at North Carolina State University.